Hey, welcome back to the videos. This is Art Lembo again, and we are going to move into our last statewide analysis of SQL data of the COVID-19 data. What we're going to do next is we're going to move into the countywide data, which is a lot larger data set, and it gets to a little more granular level, right? We're going to look at counties rather than states, and then we're going to come back around and we're going to do a geographic analysis for states and counties. So in this example, what we're going to look at is the average, the standard deviation, and something called the coefficient of variation. Now, I'm pretty sure you've all are familiar with the average and standard deviation. You've taken tests in school and you've figured out what your average grade was, and the standard deviation tells us how different a typical value would be from the average. But the coefficient of variation is a really interesting statistic. Let's think about cases in the United States of COVID-19. It's obvious that you're going to have more cases in New York than South Dakota, larger numbers, which means we're going to have a larger average. It also means we're going to have a larger standard deviation, most likely in that case. So it's hard to compare New York and South Dakota because they're just at different magnitudes. But what the coefficient of variation does is it divides the standard deviation by the average. So it gives us a relative term for how much how the relationship plays out between standard deviation and average. So this is the query we're going to use, but I want to just first show you this inner part of the query. And we're looking at that here. So I'm going to run this, and you can see what it's showing us is the sum of the increase in death. Remember, if you haven't gone through the very first few videos, you may not be familiar with what these fields are. So go back and make sure you take a look at those videos. So this tells me the sum of the positive cases for every month in the US. Now, instead of ordering it by the date, let's order it by the state and then the date. So what we can see, here's Alaska, but let's move down here. Here's Arkansas. So here's Arkansas, and let's do ascending order. That way we start with earliest and then to latest. Okay. So we look at Arkansas. So this is back in March. This is back in April, May, June, and so on. What we're getting here is that we're taking the month part from the date and returning that. And in fact, I'm going to order it by the month rather than by the actual date. That's better, right? So March, April, May, June, and so on. So you can see that for each of the states. So now if I look at, say, Alabama, I've got 13, 256, 362, 319. We're going to add all those up. We're going to divide by the total number, and then that's going to give us our increase. Now here, this is death increase. Let's call this positive increase. We'll look at the deaths later. So these are the positive cases for each of the states by month. So again, imagine I took all these numbers from Arkansas, added them up, and then divided by the 8 or the 5 or 6 months that we looked at. That would give me the average. So let's paste that other code in. So this is what we're looking at. I've now got a list of positive cases. Now what I'm going to do is I want to get the average of those positive cases. I've already got the sum, so that tells me the total cases in each month. And I'm going to get the standard deviation of those positive cases. And again, this is something that SQLite includes. stddev_samp. SQLite doesn't have the ability to calculate standard deviations, but SQLite does, and that's why we're using this SQLite GUI. And then we're going to take the standard deviation divided by the average, and that gives us our coefficient of variation. And then we're going to group it by the state. Right? We're not interested in months any longer because now we're getting the average over all the months. So if we run this, now we have every state, the average number of cases or positive cases per month. We have the standard deviation, and then we divided them and got the coefficient of variation. So let's say order by CV ASC. We'll order it in ascending order. So now I get some idea of the relative difference in cases. So you can see 0.41 all the way up to 1.5. That's the Virgin Islands. I'm not going to worry about those. We'll go look at Massachusetts, 1.3, 1.34. So you can start to see those that had larger variations. Let's look at, instead, death increase. And again, I'll just remind you, where else are you going to find the average deaths per month and the standard deviation and the coefficient of variation for COVID-19 in the United States? Nowhere except right here. You're going to be able to write that yourself. So we'll run this. So now this is another story it's telling. This tells me the average number, it's called average POS for positive, but we could call that average death if we wanted, but I'll leave that alone right now because I don't want to make the changes. But you can see a coefficient of variation of 0.46, and then a place like New York, 1.68, very high. Why is that? Well, remember, we're grouping this by months. New York got blasted in the wintertime, right? Last March and April, probably May. But New York has calmed down. So when I look at variability, I've got some months that are enormously high and others that have hardly anything in terms of deaths because it's calmed down. So that's showing that volatility, meaning New York has had some months that were really high or really low. Same with New Jersey and Connecticut and Massachusetts. But we come down here and we look at a place like Alabama, much lower. New Mexico. Now, remember, New Mexico has less deaths to begin with. But what it's showing is there's a relative stability. California is another one, very low coefficient of variation, meaning they didn't have that big spike relative to a small spike later in the year. It's probably that California's deaths were more similar each month to one another. So let's look at a state like, say, Kentucky. Kentucky has a very low coefficient of variation. And if I look at the worldometer and we look at daily cases, this is daily, this is not monthly, but notice we don't have something that New York had, this big, large K or death, and then it went way down. Here we're relatively stable. We're not varying too much from probably what the mean is. So the coefficient of variation is a number that picks that up. So we can start asking why? Why did Kentucky, why is Kansas, North Carolina, why are they more, I don't know, stable? Did it have something to do with spreading things out? Even California was relatively stable. And here again we see what California looks like. We've got a spike, so that's why it's not as low in the coefficient of variation. But you see there's this relative stability. We can look at New York as well. And here's New York. Notice the average may be around here, but there's like nothing here and things way up here. So that makes the coefficient of variation a very interesting statistic to look at to begin to think a little bit more about what's happening within a particular state. Well, I think I'm going to end this one here because I want to go to something much more sophisticated. We're going to associate population values and cases and deaths. And it actually is not, I can give you the full query, but there's a lot going on with this query, and I want to help you think through how you break a problem, a complex problem, into smaller, manageable chunks. So let's stop this video now. You can check out the next video in a moment. And again, I encourage you, please like my channel, and if you have any questions, or if you've tried and looked at other metrics about your state and how it relates to other states, put it in the comments down below. And don't forget to subscribe to the channel because I'll be releasing more videos as the week and the next couple of weeks go on.